This begins E555 with Dr. Zahid. It's Thursday, May 1st, 2014.
Thank you very much. Good morning, everybody. Okay, I checked the final exam date. Now it's official. The final exam is Thursday, May 8th. We are going to have 2 sessions from 5 to 7, not from 4 to 6. 5 to 7 and 7 to 9. The morning session is from 5 to 7. The afternoon session is 7 to 9. But you are free to take any one of them. So if you are in the first session and you want to take the second session, it's fine with me. I don't care. And the room is Salvatore 101. Everybody familiar with this? This is the one that we had our midterm in. The difference is that in this case, there will be only 1 course. In the midterm, we had 3 courses in there. And here, right now, we have 1, only the 555. And again, I will be posting the office hours and the material that is included in the final exam tonight when I get home. But it's basically all the material after the midterm. All the material after the midterm will be constituting about roughly 90% of the final exam. The material before the midterm will be restricted only to the questions on the true and false. In other words, I will not give you analytical problem on the material that we had before the midterm. But in any case, I will be posting it tonight when I get home. Okay, let's can you zoom back please a little bit? Let's continue on our overview of broadband Let's continue our discussion from last time regarding the overview on a broadband wireless network. And again, as I told you last time, that the material here will be discussed primarily in courses that will be offered in the fall. It's EE597 and the EE532. So we started looking at wireless local area network standards. And again, as I told you last time, it went through multiple variations, the 802.11b, 802.11a, 802.11g, and currently 802.11ac. And you can see that the rate increases as we move along. The 802.11b supported only 10 megabits per second. 802.11g can support 54 megabits per second. The 802.11n can support all the way to what? Also, if you see in this diagram, you can see in this diagram the data rate. The 802.11n, 802.11n can support 450 megabits per second, or even what? 600 megabits per second, depending on how many number of antennas you are using. Remember I told you last time, the 802.11n uses technology that is called MIMO. MIMO stands for multiple input, multiple output, where you are going to have multiple antennas both at the sender side and at the receiver side. At the sender side, so for example, in this case here, where you see this is the access point, or this is the base station if you would like, or the access point, and this is the what? This is the unit, the mobile unit. And you can see that you do have what? Multiple antennas. This 1, 2, 3, 4. This one has what? 2. This one we call it what? 4 by 2. 4 by 2 means what? It has 4 input and 2 output. Clear? 4 input antennas, 2 output antennas. What will this one create? It will create multiple paths. It will create multiple paths. So if this path, for example, if this path is no good, is being interfered with, the signal can still come what? In a different path. And they are going to be constructive rather than destructive. They will support each other rather than what? Rather than subtract from each other. Creating what is known as what? Spatial diversity. Spatial diversity. Allowing what? Allowing the signal to travel in multiple directions. Each one of these antennas is pointing towards some direction, allowing for spatial diversity and increase in the data rate. You can see, by the way, from this chart that the increase in the data rate is extremely what? Is extremely significant as compared to the what? To the earlier version. Now, also in 802.11n, the channel bandwidth can also be added to the old one. The old one was roughly 20 megahertz channel. Right now they have what? 40 megahertz channel. And remember, there is a direct relationship between the bandwidth and the data rate. As the bandwidth increases, the data rate that can be supported is also what? Also increases. So we have 40 megahertz. Actually, the 802.11n operate in both. But for higher rate demand, you can use what? You can use a channel of 40 megahertz channel. The 802.11n, already the product is in the market. You can go and purchase right now routers, wireless routers that are equipped with what? With an 802.11n card, and you can communicate via, wireless segment between your wireless stations and the routers. Clear? But I'm not sure if currently they are receiving or they are getting 450 megabits per second. There was a student in the second session who had 802.11, and he claimed that he is getting roughly around what? 100 megabits per second. Clear? Okay. But in any case, keep in mind always that when you see those rates for the wireless LAN, these rates only refer to the what? To the wireless segment. It's not an end-to-end. It's not an end-to-end. So if your wireless router, for example, you do have a wireless router at home, and the wireless router is attached to the service provider by cable, you are not going to get what? You are not going to get these rates on an end-to-end because the cable is not able to support that rates. Clear? These rates are only, we are talking only on the what? On the wireless link between the station, the wireless stations, and the what? And the access point. Clear? Okay. So several, and again, as I told you, the market, the number of companies, startup companies, especially startup companies that are in this business of developing products for the wireless LAN is booming. Every now and then a new company is established to work on this. And you can see, by the way, if you compare the 802.11n versus the legacy. When you hear legacy means what? Whatever is available currently. Whatever is available currently. The 802.11n versus legacy 802.11g, you can see what? You can see the increase in the what? In the bit rate as compared to the what? As compared to the distance. Clear? By the way, when the distance reaches, for example, 200 feet, the legacy cannot provide you any service. But the 802.11n can still provide you service, but at a reduced what? At a reduced rate. You see this one here? And this one at 200 feet, the legacy cannot support you, cannot provide you any support. But the 802.11 can support, but at a reduced rate. The closer you get, the smaller is the coverage. The shorter is the coverage, the rate will go what? Will go up. You can what? You can provide higher rate. Clear? Okay. Now, please, again, as I told you, you can see the number of channels and so on and so forth, how many and the rates and so on and so forth, comparing it with the legacy LANs. Now, let's now look at what? Let's look at the different one, which is called what? Which is called the WiMAX. The WiMAX is the 802.11.6. What they wanted to come up with, they wanted to come up with a standard that resembles the 802.11, but able to cover what? Much wider area. Much wider area. We are talking about roughly here what? We are talking about roughly 5 kilometers instead of what? Instead of 50 meters. Clear? But it's the same idea. Now, the only way they can do that is to make the antenna to be what? Higher. The antenna, you see these? The antenna to be what? Higher. The higher the antenna, the what? The coverage becomes what? Becomes wider. In a wireless LAN, they cannot do that. Why? Because the access point is just a small unit, and the wireless laptop is in your hand. You understand that or not? And here, no, there is a what? There is a base station in the middle of the cell, as I was showing just a second, in the middle, like this one. Before we get to the details, let me show it to you here. This is the area. So this is, for example, they divided this into what? Into multiple cells with a what? With a base station or antenna is in the middle. That base station, you can see it's a circular antenna. And this is your homes. Homes. And instead of what? And instead of extending cable or DSL, in other words, this one is a DSL replacement. It is replacing the DSL. And instead of DSL, instead of cable, they are going. Do you see this one? Do you see this one? This is the wireless unit at your home. That is the wireless unit at home. This is called what? Fixed access. Fixed access. You are not moving. You put the wireless unit in your home, this one and this one. Do you see it? This one, and so on and so forth. And they are what? They are communicating via point-to-point toward what? Toward the base station. The base station, by the way, is also connected to the rest of the world via what? Via a fiber. All of these are what? Are fiber. You can communicate. Now, still the goal is to make what? To make this one communicate with this guy, with the backbone, also via wireless. But currently, it's what? It's via fiber to the rest of the world. Clear? Now, in here, by the way, you notice what we have? You do have multiple zones that are operating at what? At Wi-Fi. Let's assume these are what? Indoors. Wi-Fi, they are operating Wi-Fi, but they can also still what? They can still use what? Use the WiMAX to what? To get to the outside. So here we have multiple what? Hotspots. They call it hotspots. Again, these are rural homes. Rural homes means what? Means you are not going to be able to extend cable or DSL in some places, which is what? Which is far away from the metropolitan area network. Okay, so they put what? They equip their homes with wireless units and they communicate with this. Clear? Now, you could also communicate with this on the move. So this is you, and you are moving. You are moving from one cell to another cell to another cell, but still be able to what? To communicate with this one here, to get the what? To get the WiMAX service. And here, for example, your laptops or your smartphones and so on and so forth, you are using technologies, for example, the wideband CDMA, the wideband WCDMA stands for what? Wideband CDMA, and so on and so forth. Overlay on this one, overlay means on top of it is the WiMAX network, allowing these also to communicate with what? With this guy. Clear? Clear? So WiMAX stands for what? WiMAX stands for the worldwide interoperability microwave access. Microwave access. Okay, this one you will take it primarily in EE 532, more than 597. I'm not sure if 597 will talk about this, but in EE 532, I'm pretty sure that the professor who teaches this will get into this. Okay, so one more time. Here we do have what? We do have point-to-point microwave links. Here we do have what? Point-to-point, sorry, point-to-multi-point, where we do have what? Multiple or portable units or mobile units communicating with what? With the base station. This is, by the way, how the base station look like. And you can see what? You can see that it's a what? It's a relatively what? Relatively tall antenna here. Tall antenna to provide for what? To provide for wider coverage. So it's unlike the 802.11, it ranges roughly between what, 5 to 6 miles, a city rather than a what, a coffee shop. A city rather than a coffee shop. Now currently it supports roughly between 14 or 15 megabits per second to 20 megabits per second. But they hope that they can get all the way to what, 100 megabits per second. Now fixed access can support higher rates than what, than mobile access. With the WiMAX can support both fixed access and what? Mobile access. With mobile access, the rate will go a little bit what? Down. But with fixed access, you don't understand what fixed access means. Fixed access means what? It's still wireless, but you are not moving. You are not moving. This is the wireless unit, and this one is the what? Is the base station. You are not moving. There is no motion. There is no motion involved. But it is what? It is a wireless connection between this one and this one. We call it what? Fixed access WiMAX. This one, no. You are moving from one cell to another, but you still maintain what? Maintain connectivity with the WiMAX base station. This is called what? Mobile WiMAX. Clear? Both of them are supported, WiMAX and, the fixed WiMAX and the mobile MAX. Transmission to and from the base station by host with omnidirectional antenna. Omnidirectional, when you hear omnidirectional, means what? Means the antenna is what? Is in all what? In all directions. Why? Because those residential places are distributed. Are you following? They cannot point to what? To one residential and then the other one does not have anything. So it's what? It's omnidirectional in all directions. So transmission from and the base station by host with omnidirectional antenna, base station to base station backhaul with point-to-point antenna. Here, but the backhaul means what? Means this guy, the one that I was telling you about. From here to here, this is what? This is a point-to-point. Whereas the other ones is what? Is omnipoint. Omnipoint means what? It's omnidirection. Means what? In all directions. Clear? Okay, good. Now, this is a differentiation between the fixed WiMAX and the mobile MAX. The fixed WiMAX, they call it 802.16d. 802.16d. The WiMAX mobile is 802.16e. The usage here, where do you use the WiMAX fixed, is for the backhaul to communicate with the backbone. A wireless DSL. Wireless DSL. When you hear wireless DSL, what does it mean? It means replacing what? DSL. Replacing DSL. So why do they call it wireless DSL? Because it provides the same rate, very close to the same rate as DSL, but without the what? Without the wire. Without the wire. So wireless DSL. The devices are outdoors and indoors installed in the customer premises equipment. This is the one that I just showed you. Where? Here. In the customer premises equipment. Customer premises means what? Within your home. Within your office. You are going to install it there. Either outdoors or what? Indoors. Sometimes they are afraid to put it outdoors. This, you see this one here? Is it outdoor? They can put it indoor and still establish connectivity, because you have to remember, RF signals penetrate walls. Are you following? Because if they put it outside, first of all, there is a danger somebody will come and what? Steal it. Steal this equipment. It's outdoors. And second is what? Is that when the weather, the environment changes, like raining and stuff like that, this might be what? Might rust. Okay, but if, definitely if you put it outdoors, the connections will be what? Will be better, because you are not going to have what? That wall providing for what? As an obstacle. Some waves will what? Some radio waves will be what? Reflected from the wall. If you put it outside, it's better. Now, usually when they put it outside, they put it on top of their home rather than what? In the lower side, so that it will be difficult to somebody will come and what? Sabotage it or steal it or something like that. Yeah, people, when they see something like this, you know, they get bad ideas if they see something which is outdoor. By the way, this is the same reason also when they extend fiber. The fiber is all what? Dug inside the ground. You don't see fiber on top of the ground, because they are afraid somebody will come and what? Steal that fiber. And that fiber costs money. It's worth a lot of money. So that when they extend fiber, they have to come and what? Dig, and they install the fiber what? Underneath the ground. Clear? Oh, by the way, that's what, when we were discussing the optical technology, that was one of the main reasons that they were very excited about the wavelength division multiplexing. Because in a wavelength division multiplexing, on the same fiber, they are going to support what? Multiple wavelengths. They don't need to extend what? Extra fiber. It's on the same fiber. They can what? They can support multiple wavelengths. Clear? Okay. Now, the frequencies, again, you can see that the WiMAX operate in what? In several ranges, the 2.5 gigahertz, the 3.5 gigahertz, the 5.8 gigahertz. Clear? Okay. Now, most of them are what? Are licensed band. Are you following? It's a licensed band. Means what? Means some service provider will what? Will pay money for the what? Pay money to the government, to the FCC, to provide you with what? With that service. Just like what? Just like your cell phone. That is a what? A licensed band. Clear? A licensed band. The description, again, wireless connections to the homes, to the businesses, and other WiMAX or cellular network tower, from one tower to another tower, and so on. So the wireless MAX, the mobile wireless MAX is the 802.16e. The usage, long distance mobile wireless broadband. Long distance, we are talking again, roughly 5 to 6 miles, long distance mobile wireless broadband. Clear, allow you to receive what? Video programming and stuff like that over what?
The time
over
is 9
longer
o'clock.
distances rather than the 802.11n. The 802.11n, the coverage is limited. Devices including what? The PC cards, the notebooks, and the future handsets, the smartphones, and so on and so forth. The one that you are using. Frequencies, again, currently it operates in the 2.5 gigahertz range, but they are trying to open a new band for this for this type of service. And then descriptions of wireless connections to the laptops, to the personal digital. PDA stands for what? Personal digital assistant. It's like personal secretary. You follow me? Not as a personal digital assistant. The enhanced sense when outside of the what? Of the Wi-Fi hotspot coverage. What does it mean? When you are outside the coverage of a what? Of an 802.11. What does that mean? It means you are far away a little bit from what? The 802.11n access point. You can still be able to what? Maintain connectivity if you do have the what? If you do have the wireless MAX service. The wireless MAX, the WiMAX, the mobile unit. Clear? And again, as I told you, this one also, this technology or this service is also, I said technology, I'm sorry. This service is also taking what? Taking shape. A lot of communities in the South Bay, they have what? They have the WiMAX service already what? Already provided by, again, who provides this, by the way, service? Again, it's the big companies. It's the big companies, the Verizon, the Sprint, and so on and so forth. Clear? Okay. Now, let's look at the cellular architecture. Cellular architecture means what? Your cell phones. Your cell phone. This is what they do. They divide or they tessellate the area into cells. Now, from here, by the way, you will see what? This one also, by the way, you will take it in EE 535 as well, which is called mobile communication. You have to keep in mind, by the way, when you take courses, that there will always be what? Some overlap. I mean, you are not going to be able to, for example, if you're going to take EE 550, which is a required class for networking majors, you will see that there is overlap with what? With 555 as well. For example, the queuing, the part of service, and so on and so forth. There is always, so I mean, you cannot complain. You cannot help it. There is always, if you are taking, how many of you are taking CS 551? Nobody is taking CS 551. Anyway, if you are planning to take CS 551, which is in the computer science department, computer networks, computer communications network, you will see also overlap with us. For example, they discussed the PGP routing, the border gateway routing. They discussed multicasting. There is always overlap. That's the nature of the school. Okay, so let's get back to what we have here. We do have what? We do have, they divide the area into what? Cells. Now, from this diagram, it looks like the cells are all what? Hexagonal. But in reality, the cells are not exactly hexagonal. They are not going to come and what? Sketch hexagonals or oval trace. This one, the reason that it's hexagonal on a piece of paper, because it's easier to analyze it when you do have what? Regular shape. In reality, the shape is like, you know, some random shape, circular or close to circular. In the middle, there is a what? There is a base station antenna with sectorized antenna. Sectorized antenna means what? Means that you can have what? Do you see this one here? Can you zoom into place a little bit? Okay. Do you see this antenna? It has direction in this direction. It has direction in here. It has a direction in here, and so on and so forth. They call it what? Sectorized antenna. Sectorized antenna. So if you look at it, can you zoom back, please? If you look at it this way, this is the center. They divide this into what? Into multiple sector. into multiple sectors, and the antenna here. So look at this antenna. This antenna is in this direction. This antenna is in this direction. This antenna is in this direction. Antenna providing this here, here, and so on and so forth. Clear? And the antennas are not what? Are not omnidirectional. They are what? Directed toward what? This one toward this sector. This one toward this sector, and so on and so forth. So we have what? We do have multiple. All of these are referred to as what? As a base station. This one is the mobile station. This is the base station. Now, what do you notice? The base stations are all connected to what is known as what? Mobile switching center. Now, when I say mobile switching center, does not mean that the switching center is moving. The switching center is not moving. When we say mobile switching center, means what? This is the center where mobile traffic, the traffic generated in here, will be switched to the what? To the backbone. What is this, by the way? This is the public switch telephone network, or the what? Or the internet. Let me ask you a question. You have a cell phone. I don't have a cell phone. Can you still call me? You cannot call me? You do have a cell phone. I have a regular phone, a landline. Can you call me? Of course you can call me. I mean, what's going on here? I have to get the cell phone to be able to talk with you. How is that? Your call will go through what? Through the base station. The base station will what? Will forward the call to the what? To the mobile switching center, and the mobile switching center will what? Will relay it to the what? To the public switch telephone network, where I am connected to. I am connected to. Clear? And the other way around is the opposite. When I call you using your cell phone, the call will go through the PSTN, and then what? The mobile switching center, and then what? To the base station, and then the base station will relay it to you. Clear? Clear? Okay, good. Now, this, by the way, does not have to be the public switch telephone network. It could also be the what? Internet. You use your phone not only to make what? Your smartphones, not only to make phone calls, but to what? To browse the web. Are you following me? When you are browsing the web, you are not going to go through what? The public switch telephone network. You are going directly to the what? To the internet. Clear? So this one, generically, I call it what? The public telephone network and what? And the internet. It's a wired network. There is no wireless in it. Everything here is what? Is wire. The wireless is only this link here. From here to here. Here to here. Here to here. These are the wireless links. Clear? Now, as you roam, this is your car, for example. As you go from one cell to another cell, you are going to hand off. We call it handoff. You hand off the call from one base station to what? To another base station. Clear? Is there a possibility that the call will be disconnected? There is a possibility. If the handoff is not quick enough, there is a possibility that the call will be disconnected, as we'll see in just a second. Okay. So the cells covers geographical region, base station, analogous to what? To 802.11 AP. So when we see base station, when we say base station, this is the same idea when we talk about what? The access point in the case of what? In the case of the wireless LAN. The mobile users attached to the network through the what? Through the through the base station, air interface. Clear? The physical layer and the data link layer protocol, the physical and the data link layer protocol between the mobile station and the what? And the BS. You notice what is missing here? One more time. Which layer is missing? The physical layer and the link layer protocol are between the mobile and the what? The base station. In 802.11, the access point, if the access point is not part of the router, it's not part of the router, it's a standalone device. The access point is a what? It's a second layer device, which means what? Does not get into the network layer. Does not get into the network layer. It's just the physical layer and the link layer protocol. The MSC, the mobile switching center, connects the cells to wider area network and so on and so forth. It manages call setup and so on and so forth. Handles mobility and so on and so forth. All of these things. Clear? Clear? Okay. Now, the cellular network, by the way, which is the fastest growing industry in all of the wireless industry. In all of the wireless industry, the fastest one is the what? Is the cell phone. You think more people have laptops or more people have phones, smartphones? Which one do you think they have more? The phones or the laptops? Huh? It's no comparison. The phones are what? Are much more than the what? Than the laptops. Clear than the wireless laptops. There is no comparison whatsoever. By the way, there are some people who don't even know how to use a computer, but they know how to use a what? How to use a phone. Clear? Oh. So keep that in mind. Now the generations of the cellular network. The cellular network. By the way, each of these cells. You see each of these cells in this diagram. They look all of the same size, but in reality, they are not necessarily of the same size. When you get to the urban area, downtown, for example, downtown LA, do you think the cells will become larger or smaller? They will become smaller. Are you following me or not? Because they want to reuse the frequency. They reuse the frequencies more often because there is a demand, more demand in what? In urban areas. In urban area, high crowded areas near the freeways and so on and so forth, rather than what? Rather than in the rural areas and so on and so forth. Clear? Also, in the urban area, they cannot afford to have what? A long antenna. The antenna becomes a little bit what? Shorter, like a what? Like a light pole. Or like the traffic signal. Did you get my point or not? The smaller the antenna, the coverage becomes what? Becomes smaller. So that the coverage is what? In other words, let me put it this way. If you are in a dense area means what? A lot of traffic. Do you expect more handoff or less handoff? You will expect more handoff. Why? Because the cells, each one of these cells becomes what? Smaller. And as you are driving, you are going to what? Exit one cell and what? Enter another cell and so on and so forth. So you will get what? You will get more handoffs between what? One base station to another base station and so on. And again, as I told you at the beginning, the technology was basically analog. They call it what? G1, analog signal, or analog phone. Currently, there are no analog phones. In other words, if you ask somebody, do you have you seen an analog phone? Have you or have you not? It's bulky. It's bulky. It's by the way, sometimes it's mounted in your vehicle, in your car. In other words, you cannot even what? Carry it. It's mounted just like the radio in your car. They put the what? They put the phone also there. So it was bulky. Always remember, in general, you do understand what is the difference between analog and digital? Yes? Okay. Rule of thumb. Everything that is analog will take more space than the digital. Digital is all because it's what? Integrated circuits and so on and so forth. Takes what? Much less space than what? Than analog. So this one was pretty big. And this one was primarily for what? For voice. A little bit of data they were able to support, a little bit of data on the downlink. Not on the uplink, but only on the downlink. Clear? A little bit of data. You can see even the digital, which is the second generation, using I will explain to you what TDMA, CDMA means in just a second. Time division multiple access or code division multiple access can support what? Roughly 14.4 kilobits per second and so on. So high or low? It's very low. Are you following me or not? Very low. The technology at that time was not very what? It was not very established. There was no such thing, for example, as a MIMO at that time. Okay. They went into the what? They went into several versions of the generation. Third generation, for example, they use what is known as what? Wideband CDMA or CDMA what? 2000, CDMA 2000. And you can see the rates have increased. 144 kilobits per second, 384 kilobits per second, 2.4 megabits per second, and so on and so forth. Clear? Clear? Okay. Now, several other technologies, for example, HSPA stands for what? High-speed packet access. High-speed packet access. Multiple releases with multiple types of modulation. Do you still remember what QAM stands for? From 450, QAM stands for what? Quadrature amplitude modulation, where you are going to change both the amplitude and the phase. 64 level QAM, and some of them are using what? Multiple input, multiple outputs, and so on and so forth. And you can see the rate is what? The rate is increasing. Remember, we are talking about what? Cellular. We are talking about cellular. This is not the WiMAX. This is cellular stuff. So 28 megabits per second, and those also the uplink now is in the picture. You can transmit on the uplink and you can receive on the downlink. The downlink, of course, is always higher than the what? Than the uplink, because you expect most of the traffic will be coming on the downlink. Downlink means what? Base station to the what? Mobile station. Uplink means mobile station to the base station. Clear? You can see again the downlink is higher than the uplink. If you compare it to the WiMAX, you can see again the WiMAX supports 40 megabits per second on the downlink, 10 megabits per second on the uplink. Then there is what? There is generation 3.9 or 4. They use what is known as what? As an LTE. LTE stands for what? The long-term evolution. Long-term evolution. They are looking at the long-term evolving of these wireless standards. Look at what the rates they are promising. They are promising rates of what? 100 megabits per second and so on and so forth. They use what? They use multiple channels and so on and so forth. Now, this is the second generation architecture. Again, as I showed you a moment ago, this is the way. This is the cellular architecture, the base stations. This is BTS, stands for what? The base transceiver station. The base transceiver station connected to a what? A BSC. BSC stands for what? The base station controller. The base station controller. Notice, by the way, this base station, it looks like a home. It's not a home. It's a switch center. It looks like a home. It's not a home. So it's the base station controller. What does the base station controller? The base station controller control all the base stations in a given what? In a given region. In a given region, this one is divided into what? Into multiple cells. This one is controlling each one of them. Clear? And then the base station controllers are connected to the what? To the mobile switching centers, to the mobile switching centers. And then the mobile switching centers going to the public telephone network. Through what? Gateways. Let's see if you still remember. What do we need a gateway for? This gateway. What do we need it for? Inside the public telephone network, the voice is digitized into what? 64 kilobits per second. Remember from port 50, the 64 kilobits per second. Yes? And the mobile and the cellular, the voice is what? Is compressed because there is not enough bandwidth to support what? Every call requires 64 kilobits per second. So they compress the voice all the way to what? Roughly 5 to 8 kilobits per second for every voice call, mobile call. Clear? Which means what? It means the technology that is used in here is not the same as the one that is used in here. So they need to use a what? They need to use a gateway. They need to use a gateway. By the way, this is more sophisticated than just a router. A gateway can go all the way to the what? To the application. Clear? That gateway will what? Will convert the voice from one format to another format to allow you to communicate with the wired phone that are connected to the public switch telephone network. Now, you can see, by the way, the TG was strictly a what? For the second generation for voice, is strictly a what? A circuit switch. This is a circuit switch. Now, if you look at the what? If you look at the 2.5G and the 3G, 2.5G is somewhere between what? Second generation and the what? Third generation. Clear? They included what? Data. Now, when the data is included, does the data go to the public switch telephone network? No, it doesn't. So it's going to go into what? Into another one, which is what is referred to as what? SGSN, which stands for what? Serving GPRS node. GPRS stands for what? Generalized Packet Radio System. Generalized Packet Radio System. And again, you have a gateway here, the public internet. The protocols that are used in here are not necessarily the same as this one here. So you need a gateway to perform the conversion from one to the other. But I need you to understand one thing here. It's just like DSL, if you remember from port 50. In a DSL, on the same telephone line, you can have what? Voice and data, but the voice will go one way, the data will go what? Another way. Same thing in here. The voice will come here, the data will go what? Will go to this one. Okay, so the key insight, in new cellular data network operates in parallel. The net, as if the cellular data network operates in parallel with existing cellular voice network. The voice network unchanged. In the core, the voice network, this one is unchanged. The data network operates in what? In parallel. Clear? Now, when I say in parallel, what does it mean? It means these offices, the offices of the switching, the packet switch and the circuit switch, are co-located. They are co-located, but they are operating in what? In parallel. In other words, different sections of the same building. Okay. Now, this is now the technology that is used for the first hop. What do I mean by for the first hop? The first hop means what? Means from the mobile unit to the what? To the base station. That's the first hop. Okay. The technologies that used are what is referred to as what? FDMA, TDMA, and what? CDMA, which I'll explain to you in just a second. Now, let's start with FDMA first. FDMA stands for what? Frequency division, multiple access. Frequency division, multiple access. So what do? Let's see if you can help me. In FDMA, this is the frequency. They divide the frequency or the band. They divide it into what? Non-overlapping bands. Non-overlapping channels. Do they overlap or non-overlap? Non-overlap. Are they transmitting at the same time? They are transmitting at the same time, but they use different what? Different frequencies. Clear? Oh, TDMA. Tell me, it looks like a toast. You are making toast. What does TDMA means? Tell me, what am I slicing? I'm slicing the time here. The frequencies are what? Are unsliced, but what? The time is what? Is sliced. Did you get this or not? And I assign different time slots to different what? To different users. Clear? Okay. What is the CDMA? Look at the CDMA. We have the time and we do have the frequency. What am I using? On the same frequency, at the same time, and on the same frequency, and on the same time, I'm going to have multiple what? Multiple users that operate what? Or that use different what? Codes. Different codes. The receiver, the base station, will be able to distinguish from one code word, from one code, than another. Clear? Than another. This is what is known as what? The code division, multiple access. Clear? And you all know, by the way, that this technology, the code division multiple access, the dominant technology in the market was developed by Professor Viterbi, the namesake of our school. Clear? Okay. While he was at Qualcomm, when he established Qualcomm, and so on. This is the race when they started. For example, look at the 4G. They called 4G the design. They started the design. Design means what? On a piece of paper. At what year? 2000. When did they deploy? When they deploy? They deploy what? 10 years longer. What does that tell you? It tells you that it takes a long time to what? To go from the what? From a piece of paper to actual what? Deployment. They need to run what? Several testing. They need to run several simulations and so on and so forth to see what? To see how the system will work and so on and so forth. Now, the third generation, again, as I told you, is using CDMA. Second generation and third generation, they use what? TDMA, CDMA, and so on and so forth. The fourth generation, they are proposing a new, or they propose already, a new technology, which is called OFDMA. OFDMA stands for orthogonal frequency, again, frequency division, multiple access. By the way, in the 4G, the core is all what? IP backbone. What does it mean when I say IP backbone? What does it mean? It means even your voice will be supported over what? Over IP backbone, which means what is referred to as what? Voice over what? Voice over IP. Did you get my point or not? In the fourth generation, even your phone call will be going through what? Will be going through an IP backbone. Not only, they see the second generation, the first and the second generation, and even the 2.5 generation, they go into what? Into the public switch telephone network. It was basically a circuit switch. And here right now, the trend is toward what? Toward packet switching to support multimedia type traffic, voice, data, video, and so on and so forth. All of them combined together. This is now the OFDM concept, the OFDM concept, which is a modulation concept. OFDM is a modulation scheme. OFDMA is a what? Is a multiple access scheme. In OFDMA, again, the frequency is divided into what? Into smaller regions, and they have the property that they are what? They are orthogonal to each other. Orthogonal means the following. Let's see if you remember. You remember vector analysis? If I tell you dot product between two vectors, do you remember this or no? What is the dot product? If I give you two vectors and I ask you the dot product, how would you calculate the dot product? You take the magnitude of one vector, you multiply it by another, the magnitude of the other vector, times what? Cosine the angle between them. But if the angle between them is what? 90 degrees, what is the cosine? Cosine 90 is what? Is 0, which means what? The dot product is equal to what? 0. What it means by orthogonal, it means what? It means these codes are not what? Are not similar in any way or shape. Is not similar in any way or shape, enabling the base station to what? To distinguish between them. Clear? Okay. The OFDMA, by the way, is used in the what? In the WiMAX, and it's also used in the what? In the long-term evolution as part of the G4, the fourth generation cellular service. Okay. And the time slots, by the way, the frequency per user is dynamically allocated versus what? Versus time slot. What does it mean? During this time slot, he is using this frequency. During this time slot, he is using this frequency. During this time slot, he is using that frequency, and so on and so on. And the frequencies are what? Are orthogonal to each other. Okay. This is, again, the 4G developments. It allows for what? Two candidates have emerged for the 4G standardization, the long-term evolution, the one I just told you about, the LTE, and the 802.16, which is the WiMAX. So if somebody asks you about the 4G, these are the two, the long-term evolution and the wireless worldwide interoperability, microwave access. And these are developed, the LTE developed by a group generation, they call it the third generation partnership project, 3GPP, which is a consortium of North America, Asian, European telecommunications standards organization working together to come up with standards for the 4G network. Okay. Now, what are the challenges? Let's look at a couple of challenges that applies to the wireless stuff. First of all, the infrastructure. We are going to have millions and millions of smaller cells. The cells becomes what? Smaller and smaller and smaller, all the way to what? Picocells. Did we see the word picocell? Picocell, we saw it when we were talking about what? Bluetooth. Femtocell is even what? Smaller than the picocells. Pico is what? 10 to the what? 10 to the minus 12. Femto is what? Is 10 to the minus what? 15. It's even smaller. How we are going to manage the interference among all of these what? Base stations. In each cell there is a what? There is a base station or an access point. Managing interference between them. Sometimes they use the same band. If it is unlicensed band, everybody uses that unlicensed band. Clear? A lot of situations appear there. How do you manage the coexistence among diverse standards? There are multiple standards. Multiple standards. Can they coexist together? Can they coexist together? Can they operate? In other words, in the same area, can you use your cell phone and still what? Access the 802.11 nearby? Clear? A lot of these issues that needs to be what? That needs to be taken care of. Mobile terminals, we are going to have what? The unit itself, the cell unit itself, or your mobile phone needs to be what? Supporting multiple standards. Currently, if you see the mobile unit, your handset, you will see what? It can support multiple standards. It can support GSM, for example. It can support Bluetooth. It can support the GPS. GPS means what? The positioning system, the geosynchronous positioning system, and so on and so forth. It needs to support what? Roaming. Roaming means what? Moving from one cell to another cell to a third cell. Roaming and the handoff mechanism. Different applications, the networking performance, and then the big headache of them all is the what? Is the battery life. These units are becoming what? Smaller and smaller and smaller. The technology, the battery technology needs to what? To improve tremendously to provide for what? Longer what? Lifetime. You don't want to what? Use it for half an hour and then what? The battery is what? Is dead. You need to what? Replace it and stuff like that. So a lot of challenges appear in the what? Appear in the as far as the wireless is concerned. Now we'll talk a minute shortly about one major thing which we neglected to talk about, and that is the what? The performance specifically about TCP in wireless network. We'll get to it in a minute. Okay, this is just, by the way, a chart that shows you the what? The bandwidth allocation. Can you zoom in, please, a little bit? More. The maximum you can go. I wanted to see it. Is it crowded? This is the band. This is the FCC. This is called what? The Federal Communications Commission allocation spectrum. Is it crowded? These are different standards, different applications, and stuff like that. Is it crowded? It's very crowded. By the way, especially where? Do you see this one? This one here, especially crowded. Are you following on? Now, as you go higher in the frequency, it becomes what? It becomes a little bit what? It becomes a little bit less crowded. But the problem with the higher frequencies is that the equipment becomes what? More costly, and the degradation of the signal, of the radio signal, as it propagates over the air, the degradation becomes what? Higher, which means what? You need to transmit at a larger power to provide for the same what? To provide for the same coverage. The service providers don't want to spend money to transmit at what? Higher powers and stuff like that. Power means what? Money. But you can see it here, a lot of what? A lot of users. Now, some bands, by the way, are what? Some bands are licensed. A licensed band means what? It operates by the primary user, whoever is paying for it. A license is what? It's open to anybody. Clear? Oh, can you zoom back, please, a little bit? Okay, good. Thank you. This is, by the way, the unlicensed band. They call it a what? An open spectrum. They call it an open spectrum. Whenever you hear the word open spectrum, what does it mean? Unlicensed. Unlicensed means what? Everybody can use it. Okay. They have currently two bands. One of them is called the ISM. ISM stands for what? The industrial, scientific, and what? Medical band. The industrial, scientific, medical band. Where does it operate? Well, by the way, you notice the slice? Slice means what? It's just a little bit of band. A slice of band, ISM, in which region? Can you guess this from the diagram? This is in the what? In the 2.4 gigahertz. And the other one is what? Is in the what? 5.5 gigahertz. Clear? One of them here, for example, is the 802.11b, 802.11g. This one is the 802.11a operating here. Clear? This. And then they opened another one. They call it the UNII. UNII stands for what? The Unlicensed National Information Infrastructure Band. National Information Infrastructure Band. Again, it's in the what? In the 5 megahertz. Sorry, I said 5 megahertz. I'm sorry. In the 5 gigahertz range. This is for short outdoor campus applications. Campus means what? Within the USC, for example, and so on and so forth. Outdoors, point-to-point links, and so on and so forth. You can see the ranges of the frequency. And the first ISM band, by the way, it even does not show in here because it's in the megahertz, which means what? Somewhere in here. This is in gigahertz. And the cordless phone. Cordless phone operate in what? In the 902 to 928 megahertz. The 2.4, by the way, and the 5.5, mostly what? Mostly crowded. Very crowded with all of these, the Bluetooth and the Zigbees and so on and so forth. Now, when they allocate the band, who's they? The FCC, the Federal Communications Commission. When they allocate bandwidth, several allocation methods exist. Auctions, for example, what? They sell the band. In other words, they advertise, they say, this band is available. Come and what? Bid for it. Once there is auction, by the way, who is the winner? The winner is the big companies, the one that has a large money to what? Pay. If you are a startup, you are not going to be able to what? To win auction because you don't have the capability to compete with the big company. So auctions raise revenue market-based but may shut out smaller players. The smaller players get what? Shut out. They don't have the coverage. They don't have the what? They don't have the money to compete. You don't understand auction means. Means if you bid more than me, it's yours. So if you do more money than me, it's yours. Clear? Okay. So upfront cost stifles innovation and so on and so forth. A beauty contest means what? They assign, FCC assigns the best technology wins. If your technology is better than his technology, your technology will win. You will get the what? You will get the ban. They call it what? A beauty contest. Unlicensed, again, as I told you, everybody can work on it, but there is a what? There is a power limit. There is a power limit. You cannot transmit as much power as you wish. Clear? Power limit. The equipment, there's restrictions on the type of equipment and so on and so on. The Wi-Fi, again, is unlicensed. Some WiMAX is also unlicensed. Underlay. What does underlay mean? Underlay, we do have what is known as a what? Primary user and secondary user. They use the same band. They use the same band. The primary user is the one that transmits at what? Full power. The secondary user, there is a strict power limitations on the what? On the secondary user. Somehow the secondary user needs to be what? Hiding himself below the what? Below what is known as the what? As the noise level, so that the primary does not feel that there is a secondary in there. That's why they call it what? Underlay. Underlay means what? Lower. Are you following me on that? Okay, and here the technology that they trying to use is what is known as what? Ultra-wideband. And an ultra-wideband, your signal would look like what? Would look like noise. Ultra-wideband, because the noise expand over what? The power in the noise is distributed over wide bandwidth. Clear? Same thing with this signal here. Cognitive radio. A lot of work is done in cognitive radio. Let's understand what it means. In a cognitive radio, I am the primary user for this band. I am the user for this license, for this band. A secondary user comes and sends the medium. If the primary is not using it, the secondary can what? Sneak by and what? Uses that band. Are you following one? But once the primary comes, the secondary needs to what? Needs to leave. Did you get my point on that? Needs to leave. Now what will he do? The secondary. He will go and sense other what? Other portion of the spectrum that is not used. So he keep jumping. Who's he? The secondary user. He keep jumping from what? He keep jumping from one spectrum to another spectrum to a third one. Whichever is not what? Whichever is not used, he will what? He will jump and what? Use it for a short period of time and then what? Jump to the other one. Jump to the other one. They call it what? Cognitive radio. The primary user has a priority. Secondary user can use greater power but has to detect and vacate the spectrum when the primary users what? Come up. See the difference between this one and this one. In the underlay, there is a strict power limitation on the secondary users. In here, the secondary user still can transmit at high power, but only after detecting that the primary user is what? Is not there. Clear? Is not there. Then he can transmit. Once the primary user comes, the secondary user needs to what? To jump to another place. Okay. Now, the evolution in the handset. This is in your handset, in your smartphone. It went through what? It went through multiple applications. Look at this one here. Currently, for radio interfaces, you do have what? You do have a Bluetooth, you do have a Wi-Fi, you do have a what? The wideband CDMA for the cellular architecture. You could have a what? GSM, you could have a what? LTE. These are what? Multiple standards to provide for different types of application. Circuit type application, voice over IP, the digital video broadcasting, internet video, data, handovers, and so on and so forth. All of these types of applications. And again, the performance of the battery life needs to what? It's related to the what? To the range, the channel conditions, the radio interfaces, the interferences, the handover scenarios. All of these are related to the what? Are related to the battery life. Clear? Okay. Now, before we get into that, let's use the pad a little. Are you following me so far or not? Okay. Let's look at overview of TCP performance over what? Wireless. TCP performance over wireless. Now, let's see why we are interested in this one. Why, by the way, this one you will take it again in EE 532 and maybe EE 597. How many of you have taken this? None of you? How many of you have taken this? How many of you are planning to take this? You will see that you will get a little bit into what? Into TCP performance. What is the problem with TCP? Let's see. TCP is a reliable protocol. Yes? Which means what? It means that he needs to perform what is known as what? Congestion control mechanism. In a congestion control mechanism, let's see how much you remember from 450. Congestion control mechanism, how does TCP know that the congestion has occurred? What should happen? What should happen such that TCP knows that congestion has occurred? The network does not tell it. Either the timeout mechanism occur, or what? Or the sender receives 3 duplicate acknowledgement. Do you remember that? From whatever, 450, or even our class at the beginning of the semester, we discussed. Now, why is it so difficult in wireless? In wireless, most of the time, the reason that a packet gets dropped is not because that the network is what? Is congested, but because there were errors in the what? In the packet. There were errors in the packet. Remember, in the network, if the routers detect what? If the routers detect errors, they will just simply what? Drop it. Drop the packet. Because the channel environment is so bad, what will happen? What will happen is that the packets are going to be dropped because of what? Errors, not because of congestion. Yes? Now, the TCP sender thinks that the reason for it is what? What was the reason for the packet get dropped? He thinks that the reason is what? Is that the network is what? Congested. Why? His timeout has what? Expired. What does he do? When the timeout expires in TCP, what does he do? He what? He reduces all of his, he reduces his window size all the way down to what? To 1. You remember this or not? Yes or no? He reduces all of his window size to 1 and starts slowly again. Yes? Is that efficient or not efficient? It's not efficient. Why? The network is not congested. The network is not congested. The packet was dropped because what? Because the errors, there were errors in the packet. It's not because the network was congested, but the sender doesn't know that. Okay. So I want you to understand I made a couple of, these are not in your, but I will be posting it. Let's understand the problems here. So TCP loss handling and wireless. Just listen to me, I will be posting it. This is from another class. So TCP assumes that the packet loss implies what? Congestion. TCP assumes that the packet loss implies congestion. What is his reaction? His reaction is to reduce the sending rate, i.e. reduce the what? The window size. If he reduces the window size, the throughput will get what? Will get reduced as well. Clear? In the wireless environment add losses. The losses are due to what? Corruption. Corruption means what? Corruption does not mean political corruption. Corruption means what? Means the packet has what? Error, got corrupted. Collision. Let me ask you a question. When there is a collision, you do understand collision is not the same as congestion. Collision is what? Is when 2 users attempt to transmit at the same time. When there is a collision, is the packet lost? When there is a collision, is the packet lost? Is the packet damaged? Not because the network is what? Congested, but because there was a what? There was a collision between multiple users trying to use the same medium. Clear? Oh, so collision. Handoff. What does handoff means? Moving from what? From one cell to another cell. The handoff was so slow, the connection was what? Down. Which means what? Some packets got what? Lost. Is it because of congestion? It's not because of congestion. It's just because you are what? You are moving from one cell to another cell. You need to what? You need to hand off the signal. So what is the goal here? What is the result? Result is that the reduction in the window size due to random errors, the reduction in the window size due to random errors is what? Is unnecessary. It's really unnecessary. The sender should not have what? Should not. By the way, what should you do? Listen to me. What should you do if the packet was lost because of errors? What does the sender needs to do? Ideally, let's assume the sender knows that the reason what? The reason for the packet to get lost is because of errors. What should he do? He should send again right away. He should retransmit again right away. Are you following? He should not reduce his window, because reducing your window, it means what? You are underutilizing the available resources in the network. The problem is that he doesn't know that what? That errors occurred. Okay. So reduction in the window size due to random errors is unnecessary. Desired reaction, retransmit lost packets quickly. Retransmit them quickly. Are you following me or not? Clear? But TCP, again, as I told you, TCP assumes what? Assumes that the network is congested. Okay. But could the congestion response be the appropriate response for errors? In other words, when errors occur, could congestion be the appropriate response? Congestion control be the appropriate response to the error handling as well? Let's look at this scenario, see if you can help me. Let's assume that we do have a CDMA channel. In a CDMA channel, what did I tell you? I told you that there are multiple users that are using the same what? Channel, but at different codes. Clear? At different codes. If the interference increases between those users, what will happen? What will happen is that the packets will get what? Lost. Errors will what? Will occur. You follow me or not? But when we say interference from other users, that is the same as saying that there are many users trying to what? Access the network at the same time. I'm not sure you are following me here. Did you get my point or not? No, you lost me here. You lost me here. Can you concentrate? Concentrate a little bit. You remember CDMA? We talked about it a moment ago. What does it stand for? Code division, multiple access. In a code division, multiple access, all the users can transmit at the same what? At the same time, at the same frequency, but with different what? Different codes. These codes, as they propagate, they will what? They lose their orthogonality and they start what? Interfering with each other. The more users are transmitting, the interference will go what? Will go up. When the interference goes up, chances of errors will go up. Chances of the packets dropped will also go what? Up. Are you following me or not? Okay. The sender, if he slows down, is that the proper things to do in this case? In this case, is that the proper thing to do? That is the proper thing to do. Why? Because the packet was lost because there were many users trying to what? Trying to access the network at the same time. Which means what? It means that the network is getting what? Congested with users. So even though the packet was dropped because of what? Because of error, because of interference, not because the network was congested, but the reaction of the sender should be what? Should be to reduce the what? The rate at which transmit. Because if you keep transmitting at that rate, if every user transmitting at a higher rate, the interference will what? Will persist. But did you get my point or not? Will persist. So the point that I'm trying to say in here is that the reaction that TCP will the way that he will react to the timeout, in some cases might be the appropriate reaction. He should react that way in this situation. But in a different situation, when a packet is in error, not because of what? Multiple users, but because of what? The environment, he should not what? He should not drop his window size all the way to the what? All the way to the minimum. So if the noise causes the errors, if the noise causes the errors, it is not appropriate to what? To reduce your window. But if the errors are due to what? Interference, it is appropriate to reduce your what? Your window. Did you get this or not? You will see this one in the true and false in the final. Did you understand it? One more time. What does it say? If the errors are due to what? Noise, then it is not appropriate for the sender to what? To reduce his window. That error was caused by what? Noise. Did not cause it, was not caused by what? Interference. Clear? But if the errors were caused by what? Interference from other users, that's an indication that the network is what? There are a lot of users are what? Using the network, and you should what? You should reduce your what? Your rate of transmission to relieve the what? Relieve the interference into the other. Clear? Okay. What if the channel was in a bad state for a long period of time? What if the channel was in a bad state? Bad state means what? Means it's generating errors a lot for an extended period of time. Would you be better off if what? Would you be, who's you? The TCP sender. Would you be better off if you reduce your rate? You are losing me here. You will have difficulty in the other classes if you are not getting these points. Did you understand what this means? If the channel was in a bad shape means what? Environmentally, obstacles, reflection, refractions, and so on, scattering, and so on, raining. It was in a bad shape. The TCP sender, if he reduces his rate, would he be better off? No, he would not be better off if he keeps sending at a higher rate and the channel is what? Is bad. Does it make sense to you or not? Does not make sense. Does it make sense? You should what? You should slow down. Are you following me? Or you should slow down. By the way, is the network congested? The network is not congested. Just the channel happens to be what? In a bad state for a long what? For a long period of time. Clear? So there is different situations that might what? That might occur. Now, in another thing, in the case of what? In the case of a wireless channel, the errors might come in what? In bursts. What does burst mean? For somewhat, you don't understand what is the difference between a random error and bursty error. Random error means what? Any bit can be in what? In error, randomly. And burst means what? Errors will occur in a what? Continuous style, affecting a burst of your data. Clear? A portion of your data will be what? Will be wiped out. Clear? So if it affects, if the wireless link remains unavailable for extended duration, like a window worth of data may be lost, for example, during driving through a tunnel. When you are driving through a tunnel, the tunnel will behave as an obstacle to radio signals. Chances are you will get what? You will get error for an extended period of time. Why? The tunnel is not that short. Clear? Or, can you explain this one to me? Passing a truck. What? Why passing a truck? While you are driving, you are passing, the truck is what? Long trunks. Not the trunks. Long trucks. Yes or no? Those, for example, carrying food to the department stores or gasoline and so on and so forth. So your data might be affected over what? Over some period of time. Clear? In this case here, there will be multiple what? Timeouts. Do you agree with me or not? There is going to be multiple timeouts. Multiple timeouts results in what? You keep going into the what? Slow start. You keep going into what? The slow start. Slow start, which means what? You will spend most of the time in a which phase? In the slow start phase. You still remember the slow start phase? You go into the slow start phase, which reduces what? Congestion window to 1 MSS, reducing the throughput. Reduction in window in response to bursty errors may be what? Unnecessary. Why? Is the network congested? The network is not congested. You just happen to pass through what? A big truck or a what? Or through a tunnel or something like that. The network is not congested. But because of what? Burst error, the timeout keep what? Occurring continuously. And the sender keep going into what? Keep going into the slow start, and so on. Clear? Clear? And again, as I told you, you will study different situation in subsequent classes. Another one I want to bring it to your attention, and again, this one you will study in EE 532 and 597. Let's see if you can follow this. This is what is known as MANET. What is MANET stands for? It's Mobile Ad Hoc Network. Mobile Ad Hoc Network. What does ad hoc means? No wires. Clear? So this is what we have. We have multiple what? Multiple units. Yes? Multiple units. If this one wants to what? Communicate with this one. You notice, by the way, this one here is outside the coverage of this one. So it has to go through what? It has to go through what? One hop, another hop, a third hop. You follow me or not? Now, this is, if you look at this one here, the network is like, the nodes are connected like this. Are you following me or not? Yes or no? What happened here? This is the same scenario. What happened? This one moved. This one moved. Remember, there is what? There is mobility involved. Now they are like this. Did the route change? The route changed. Did you get my point or not? The route changed from here to here. So we need to what? As you traverse multiple links. By the way, why are you going through multiple links? Why are you going through multiple links? You are going through multiple links because this one cannot what? Access something which is outside its coverage, and the coverage is limited. It has to go what? Into multiple hops. But as they move, the route has what? Has changed. Look at this route and look at this route. They have changed. Are you following me or not? How would TCP react to these changes? Now, notice, by the way, once the route changes, will the RTT change? The route changes. Will the RTT also change? The RTT will also change, which means what? The TCP will get confused about what? How to estimate to get the RTO. RTO means what? The retransmission timeout. How does he set the timeout? He needs to set the timeout based on the what? Based on the RTT. Clear? Clear? All of these problems, you will study it in a little bit more in detail in these two courses. I'm just showing it to you, an overview. Okay, let's get back to this and try to wrap it up. This is a mobile network society. We are living in a society which is everything is what? Is wired. You can see that in what? Surveillance systems here, sensor network. Sensor network, by the way, another class is EE 652, which is called sensor wireless networks. And this one also is offered in the fall. Sensor networks here, transportation, vehicular networks, the trucks, everything via wireless. This one can communicate with this one with this one, ITS. ITS stands for the Information Transport System. Information Highway System or Information Transport Systems. Clear? Information Technology Transport System. Ad hoc network all over the place, disaster, emergency alerts. Why? Because if something happens like an earthquake or a tornado or something like that, all the wires and the cables will not be what? You will not be able to use it because they will be damaged. But the wireless, you can still use it. Why? Because it's in the air. So disaster, police, delivery, the UPS, and so on and so forth. It's like everything is what? Is connected via what? Wireless links. And you can see, by the way, the indicator, the telecommunications, as compared to the what? As compared to the other users, way, way, way up. And this one goes all the way to 2009, which means what? A little bit outdated. Did you get this or not? But you can see the growth corresponding to the what? To the other one. What are these? Fixed telephone lines, fixed broadband subscribers, internet users, and you can compare all of these. By the way, who are these? These are internet users, the people who are using the internet. This one is the people who are using the what? The mobile. you can see it's more than the what? More than the internet. That's what I was just telling you about a moment ago, that there are people who have cell phones, but they don't know what, they have no idea what they don't have laptops or something like that. Clear? This is, again, you can see the applications, voice over IP, videos, P2P. P2P means what? Peer-to-peer. Peer-to-peer type of applications, web or data access, and so on and so forth. And by the way, this one goes to 2014, which is our currency. And how many users? We are talking about 3.5 billion and so on and so forth. Clear? Okay. This is finally the overlay of a broadband wireless networks, regional, metropolitan area, campus area network, indoors. Indoors is the what? Is the femto cells going from the indoors to the what? To the campus. It's like a what? Overlay. It's like one network on top of the other. One network on top of the other. This is the indoor stuff. Goes to the what? Goes to the campus. The campus can relay it to the what? Metropolitan area network. Metropolitan area network can go to the regional. Regional, by the way, through a satellite, can reach what? Can reach other networks and so on and so forth. Everything via what? Everything via wireless. It's called what's known as the vertical line.
Professor, we are now out of time.
Oh, okay, thank you. We are out of course also. So, the semester is over. Good luck in your exams. And remember, I will be in my office this Saturday. If you don't have any questions, I will be posting, by the way, tonight, another sample set of some other problems in optical networks and stuff like that for you to experiment with. Good luck.
This concludes the 555 with Dr. Zahid. It's Thursday, May 1st, 2014.